Preparing to live stream.
Hey, welcome back. This is the second week of the Advent of Code event. We're just going to be walking through solutions for Advent of Code 2021. If you don't know who I am, if you didn't listen in last week, my name's Floyd. I'm the owner of a small software consultancy called Canyon Trail. I've been writing software professionally for about 20 years. And I'm just doing this event to just try to help people have fun doing Advent of Code, hopefully to help folks learn some stuff. And my camera is misbehaving. There we go. All right. I'm going to be having some guest presenters. You can be one of them if you would really like to do that. We're going to have some contact information here in just a second. If you're interested in being a co-presenter, maybe next week or the week after that, we're going to be doing this every Thursday in December. So if you're working on these Advent of Code problems, you find one that you just really had a great time with and you want to talk about how you worked through your solution, we'd love to have you on stream. And as a matter of fact, one of our guests today is going to be Matthew Lee. He's going to talk about his solution for day 3 in TypeScript. As you notice, he's already got 8 stars for the 2021 event, which means he's done roughly 4 days problems. That means part 1 and part 2 of each day. He's done at least 4 of them. He may have gotten another star since I got him to send me this screenshot. So Matthew's joining us from Deep Fork Technology today. He's got less than a year of professional experience, and so really super proud because this is such a big step. He's done an amazing job with the code that he's written so far, and he's self-taught. So if you're one of those self-taught people and you're trying to break into the software industry, Matt's a great example of this is how it can be done. So what to expect today and the remaining Thursdays throughout the month of December. We're going to talk about concepts. We're going to talk about fundamentals. We're going to pick apart the problems that we've solved in Advent of Code and help you understand why do they work the way that they work. You're going to see TypeScript and Python solutions. I will tell you, I didn't get all of my Python solutions caught up to my TypeScript solutions. So there's going to be, I think, 1 or 2 Python solutions missing, but I'll work on getting those caught back up. You're going to see some unit tests, and some of those unit tests are going to be representative, at least for my part, for the ones that I work on, my problem-solving approach and my thought process as I sort of learned my way through solving these problems. You're going to see code on GitHub, so if you want to download the code yourself and play with it and experiment with it, you're free to do that. And we've got some discussion happening on the Techlahoma Slack organization, so we'd love for you to join in with that. What not to expect? Come on, camera. There we go. What not to expect? We're not going to do a whole lot of live coding. We are probably going to be doing a little bit of experimenting today in the REPL just to see how certain functions work, but we're not going to be live coding the actual solutions to the problems. Don't expect perfection. There's going to be audio video mess ups. There's going to be imperfect coding solutions. We're all human, and we're just going to lean into that. Don't expect one true answer. There are many, many different ways to solve these Advent of Code problems, and what you're going to see on stream is 1 or 2 potential ways. Pardon me. And also, don't expect timely solutions. Like I said, I'm still not quite caught up on the Python side of this, so my apologies. We'll get that caught up and keep an eye on the repository for those Python solutions as soon as I get them caught up. If you're interested in doing this and you kind of feel like, okay, I'm just sort of doing this on my own, you don't have to. Get yourself an invite to the Techlahoma Slack organization. So it's kind of like a shared chat room for everybody. You can get there from slack.techlahoma.org. We have these 3 channels where some Advent of Code discussions already happening. Of course, the Advent of Code channel, the JavaScript channel, TypeScript stuff goes here too, the Pythonista channel. So if you're doing TypeScript or Python, here's what to do. You're not restricted to those languages. You can pick whatever programming language you want. I've already had some interest from folks who would like to present their solutions in interesting other languages. We might have some Perl on here later this month. I'm already kind of getting itchy about that, though. I'm kidding. I'm kidding. There is a template repository. If you're using TypeScript and or Python, you can download this template repository, or fork it, I should say, so that it'll give you kind of a quick start for running your code, running your tests, so that you don't have to do that all yourself. The solutions repository is here. And the solutions repository has all of the solutions up to what you see today on stream, and it'll continue to get updated as me and the other presenters who are going to be presenting later on this month get their solutions built, and we look through them and we're like, yeah, let's show this on stream. It's okay to struggle. I'm struggling myself. I still haven't finished day 8, and today is day 9. Day 8 was kind of hard, and I think I've got a solution for it, but I still haven't proved it out yet. So you're going to learn stuff through this process. It's okay if you get stuck. It's okay if you need to ask for help. It's okay if you're like, maybe this isn't for me, but I'd love for you to still stick around, watch on stream, and learn stuff. All right. So let's start talking about day 2. So we looked at day 1 last week because last week was, what was it, December the 2nd, right? So I didn't really get a chance to get day 2's solution done and then be able to talk about it on stream. So let's talk about day 2. Let me pull Mr. Code over here. All right. So I'm going to start with, and then let's get this zoomed in like that. I'm going to start with TypeScript. So if you remember the day 2 problem from Advent of Code, and if you're following along on Advent of Code, it's at adventofcode.com. You should be able to navigate there pretty easily. The whole idea behind day 2 is you get a list of instructions like this right here, and you have to use those instructions to figure out what is the X and the Y position of a submarine based on it following these instructions. Now, you could just sort of make a loop and do that, but I thought this was a great opportunity to talk about object-oriented programming. So both Python and TypeScript are ostensibly object-oriented programming languages. So let's talk about the object orientation approach that I took for this. So over here on the left, Kimberly, can I get a font size check?
A little bit bigger would be better.
Let's do it. There we go. All right. So over here on the left, we have these types, instruction and instruction-based. So instruction-based really is just sort of helping me get rid of a little bit of boilerplate, but the key element here that I want us to look at is this instruction type. So it's got an argument, which is a number. So each of these instructions, so if you look over here on the right, each of these instructions has a numeric argument, and I'm just calling it arg. And this instruction, so for part 1, it takes a position and gives me another position. So I have an instruction for up, and I have an instruction for down, and I have an instruction for forward. So if you notice, my reduce part 1 for up gives me a position where the X coordinate is the same, but the Y coordinate is the original Y coordinate minus the arg. So if you remember from the description in Advent of Code, up means we're taking the submarine up, which means it's decreasing in depth. So that Y coordinate is the depth. So you go down, you get deeper, that Y coordinate increases. You go up, that Y coordinate decreases. So here's up. So naturally down is going to be Y plus the argument. Makes sense. Then forward for part 1, we're just changing the X coordinate based on the argument. So this is pretty straightforward. Now, what we could do potentially, and what is a completely reasonable solution, is we could just do a loop. We could see, is it forward, is it down, is it up? And then we could go, if forward, then do this thing. If down, then do this thing. If up, then do this thing. But with an object-oriented approach like this, one of the things that we can do, which is really neat, is and I don't know why I labeled this offsets. This is a terrible variable name. As a matter of fact, let's fix that. There we go. I lied to you. We're doing live coding. Ah! Okay, so what we've got here is an array of instructions. And so you can see this is just an array of instructions. So what we're doing now that we've turned all of these instructions into these instruction objects, we've parsed them into instruction objects, is we're going to do a reduce. Now, what is a reduce? A reduce takes an array and smooshes it together into a single value. And a reduce uses something called a reducer function. So a reducer function takes whatever your accumulated value is, and then whatever the current value is in the array, and does something to smush them together. So if you want the sum of an array, your reducer function is a function that adds the left operand and the right operand. So this plus that. There's a reducer function to give you a sum. So that might give you a hint as to why I named my functions in my instruction object reduce part 1 and reduce part 2, because I'm taking my initial position, x at 0 and y at 0, and I'm doing this reduce. And if you remember, this reduce takes a position and gives me a new position. So all we're doing here is walking through each instruction and having that instruction tell me, given this point, what's the new point based on this instruction? And that's it. Now for part 2 was a little bit more complicated, just a little bit, because the instructions were really about, we're going to aim the submarine up or down so that forward not only moves the submarine forward, but it also moves it up or moves it down, depending on what the aim is set at. So instead of just a position with an X and a Y, here we've got an X and a Y and an aim. But again, the technique is exactly the same. We're just going to walk through the instructions using a reduce. We're going to take the state, hand it to the instruction, and the instruction is going to say, okay, here's the new state of the submarine. And then we walk all the way through that. We have our final state, and then we can multiply the X and the Y from the final state to get our solution. Let's do this. First off, one of the things that I did as a part of building this solution is I wanted to make sure that my parsing worked right. So if you notice, I built some test cases. So I've got my instructions. So I just split these along a new line, my expected arguments, and my expected class names. So for each of those instructions, this is a really neat technique that you can use in JavaScript and TypeScript. I'm programmatically generating test cases in my test here. So for all of these instructions, for all of these expected numbers, and for all of these expected class types, I'm making sure that the arg is what I expect based on it. I'm also making sure that these class names are of the expected type. So when I run this, so let's actually do that real quick. And again, Kimberly, a font size check would be super.
That's okay.
Okay, so let's do npm test. Oh, why is it not showing me all of my test output? Let's ask the Googles real quick. Aha, there we go. The npm test verbose. All right, there we go. So we're talking about day 2. So if you notice, we've got all of these individual tests. So instruction forward 5, it should have arg5, it should have type forward. So this is me walking through a number of test cases and making sure that each of those individual instructions gets parsed right and gets instantiated as the right class. So these are the kinds of tests that you can do to sort of break down a bigger problem into a smaller problem. Okay, did I turn the text-based instructions that I got from my sample input into the right classes with the right data inside? So this is a great way to break this down into a smaller problem, solve the smaller problems, so now you have less work to do. Let's take a quick look at the Python solution, because it can be really helpful. Let's see, day 2.py. All right. Come on, over here. There we go. All right, so very, very similar with Python. Init is Python's equivalent to this constructor function for TypeScript classes. Now, if you notice, there's something kind of different about my Python solution. I'm just going to collapse these up real quick, just so we can sort of see the file structure here. So in TypeScript on the left, we've got an instruction type, and we've even got a base class for our up, down, and forward classes. Over here in Python, we don't have a base type, or we don't have a base class. We just have these classes. This is a difference between TypeScript's type system and Python's TypeScript type system. So Python is what's called a dynamically typed language, so are also known as duck typed. So in Python, if it waddles and if it quacks and if it swims, it's probably a duck. Whereas in TypeScript, unless you say it has this interface with some subtleties, it's not a duck. So the nice thing about that on the Python side is that there's less type bookkeeping to do to create this solution. And in this particular case, so I didn't use a reduce. Reduce is kind of weird in Python, and it doesn't look like normal Python. So instead, both for part 1, part 2, you'll see me looping. But really, the guts of that loop is exactly the same. So here's my part 1 solution in Python. Here's my part 1 solution in TypeScript. So this bit right here in TypeScript is exactly the same as this bit right here in Python. So this reduce, you could rewrite that reduce on the left with a loop that does what you see on the right. All right. Kimberly, anything from the Twitch channel?
No, just a couple of comments, but no questions or anything.
All right, super. Okay, so let's talk about day 3. Matthew, this is your code.
It is.
All right. So tell me the story about you attacking this problem. Help me understand, like, what was the hardest part for you? What did you learn from this? What fun did you have?
Yeah, so trying to refamiliarize myself with the problem. So I guess probably the most fun I had, or like I guess exciting realization sort of when it clicks, is just figuring out that whatever I did so the problem was broken down into 2 parts. It's like find the most common and find the least common, and then thinking about it, just knowing that the least common is just the most common in reverse.
Yeah. Okay. So one of the things when I saw your pull request for this particular problem, I saw this unzip with function in here, and I looked at it, and there's just so much going on here, and it's really, really clever how you solve this problem. So on last week's stream, we talked about the zip operator, and we compared and contrasted how zip works in TypeScript versus Python. But now we have this unzip thing. So what is unzip compared to zip?
So for zip, you're basically taking an array of arrays and then just sort of merging them down and stacking them on top of each other.
Mm-hmm.
And zip, you're reversing that process, so you would get the original arrays. So what I did here is, in order to basically map the columns to rows, I just did an unzip in the width. The unzip width performs a function on the unzipped rows, which would be
okay.
Probably
okay.
But
so I was playing around with this in the TypeScript REPL, and so I've got some sample data here. Okay, so we see the sample data, and so I've just got an array of arrays, and so let me also underscore equals require Lodash. There we go. Okay, cool. So let's play around with this zip and unzip thing. So if I do zip underscore dot zip of sample data, I don't know why my REPL has got so much lag in it. 0 and sample data 1, it's going to give me an array of arrays. And so each element it's the first one from the first array and the first one from the second array. So 1, 4, 2, 5, 3, 6. Now, let's see what happens when I unzip this. So let's unzip our sample data. So what happened here? It looks like we took, so let's say these were our rows in our original thing, it turned our rows into columns. So instead of an array of rows, we have an array of columns now. And back to your solution, so unzip with, so we start with our rows, so each individual entry, and then this unzip is going to turn those rows into columns. And then there's something really cool that you're doing right here with this arithmetic. So you're doing a sum, you're doing a division, and then you're doing a round. So what's going on with that? What is that?
So basically, like, I just average all of the bits and then round it to the nearest integer. And since it's either 1 or 0, that'll give us the most common bit in that column.
Okay, so you add up all of the ones. So you treat all the ones like ones.
Right.
You just add them up and then divide by the number of entries. So if we've got 30 entries and there are 16 ones, then our sum's going to be 16. We're going to divide it by 30. So 16 divided by 30 is going to be something greater than 0.5. And then you round it, and that's going to round it up to 1. So that 1 says the most common bit here is 1.
Correct.
Awesome. Awesome. Now, what's amazing about this is there's so much packed into this. And there's a fair bit of familiarity that you have to have with unzip with and the behavior of round and all of this. But definitely when you see a sum of things divided by a length of things, like that ought to clue you in, we're doing an average. That's really cool. So talk to me about this parse decimal thing. What does that do?
Yeah, so there's actually an easier way to do this, which I didn't know about, but basically the idea was that I have an array of bits and I need to convert those to a decimal. So knowing that a bit to decimal is for each bit based on the position, it's just a power of 2, and then you add it up. So if you have like 1001, then you would have 1 to the 0th power, 0 to the first power, 0 to the second power, 0 to the third power. And so I just loop through them, and based on the index, I calculate what the exponent would be, and then sum them all up. So
what's really interesting about this parse decimal is it turns an array of ones and zeros, basically a binary number that's just been split up, and turns it into what is the actual decimal number that it's supposed to be. So in effect, you wrote a binary number parsing function. And although, yes, there's a built-in JavaScript way to do that, I think this is really cool, and it's really instructive because it helps to sort of solidify the relationship between here's how things are represented in binary, and here's how to turn that binary representation into the actual numeric representation of the same number. this is a great exercise to do just in general if you're trying to understand what's the relationship between binary numbers and actual numbers. In general, you don't do a whole lot of binary arithmetic in normal day-to-day programming. I don't know. Is that something that you use relatively often, Matthew?
I have never used that.
Yeah, and like I'm kind of an old fart when it comes to software development. I've been at it a while, and I also cut my teeth at some pretty gnarly technical places where, like for instance, my first company that I worked for while I was even still in college was an image processing company. And this is like companies who figure out really clever and really fast algorithms for dealing with, image data, JPEGs and bitmaps and that sort of thing. So there's a lot of like bitwise arithmetic that happens there. But honestly, getting away from that arena, it's bitwise arithmetic is just not something I use on a day-to-day basis. But when I need it, it's nice to have that solid understanding. And so seeing this, like it warms my heart because it's like, people understand the binary. I love this. Were you tempted, Matthew, to try to come up with some sort of bitwise arithmetic way to solve day three's puzzle?
Oh, definitely.
The description really sort of led me, like, I immediately started thinking, okay, do I do an XOR, an exclusive OR? Like what, like, did you go through that same thought process?
Yeah, I think it's sort of like a trick on the mind. Whenever you see like bits involved in something, you're automatically like, oh, I get to do bit manipulation.
Yeah.
Like,
Yeah. And that's one of the things so this is your second year of Advent of Code. And do you remember, like last year, I definitely remember the past few years. Do you remember like the description sort of steering you into a direction, sort of leading you down the path of this is how you solve this problem, and that was actually the wrong way to solve it?
oh yeah, definitely.
Day 6, I feel like this year was a whole lot like that, and we'll talk about day 6 here in a minute. So for your day 3 solution, is there anything else in this solution that was really like noteworthy or fun or difficult for you that you want to talk about?
I mean, pretty much just what you covered. There's also one thing that I just think is an interesting programming trick, and it's the simplest thing, is in my calculate epsilon from gamma function.
Epsilon from gamma. Okay. So yeah, this one is actually really interesting. So this one you used in your part 1 as well as in your part 2 solution. So talk about that. Talk about that a little bit. Because that is that's another one of those. Do you really understand how binary numbers work?
Yeah. So knowing that our gamma was the most common number, or so since it's the most common number, the other number has to be the least common, and our options between most and least are 1 and 0. So knowing that, you can leverage the fact that 1 minus either 1 or 0 always returns the opposite. And
right.
That's not something you have to do. I just think I'm sure there are other ways to do it. That's just one of my favorite things because it's so simple. Because I would think, okay, well, what do I have to subtract from the number in question to get to what I want? But sometimes it's like sort of the other way around, swapping your variables.
Right. And because we're dealing with, we're not really dealing with the binary itself. We're dealing with an array of numbers that are either 1 or 0. You have to do that subtraction to flip the bit. But like this is one of those bit twiddling things that you find yourself doing a lot when you actually have to deal with numbers in binary. And if you were representing that gamma as an actual number, this is literally just a bitwise inverse. And in a lot of languages, it's just the tilde operator. So just like the negative operator flips the sign, the tilde will flip all of the bits from 1 to 0 and 0 to 1. But I think this is really interesting and really cool that you picked up on this rather than recomputing over the whole data set again.
Yeah, pretty proud of that.
Yeah, this is really slick. So thanks for being on stream with us. You're going to be hanging around here, and so if you've got any comments or anything like that as we continue on, please feel free to jump in. I think we're going to go ahead and move on to the day 4 solution, and I had some notes around here somewhere. Where did I put those? There are my notes. All right, so I want to play with this zip and unzip a little more. So we've got our sample data here, and so we've got let's just call these rows. So 1, 2, 3 in the first row, 4, 5, 6 in the second row, 7, 8, 9 in the third row. So watch this. This is something that I think is really interesting about zip and unzip. So if I do zip on my sample data, it produces something kind of crazy. So it gives me an array of number, but I can also do something very interesting with zip. So if you're not familiar with what this syntax is, that triple dot right there says, treat the contents of this array as though each element is an argument to the function. And when I do that, I forget what I think they call it the argument spread operator. I'm used to calling it splat because it's just faster and easier to say. When you do that, it behaves exactly like unzip. So check this out. We get the same data. So what's interesting about this is really zip and unzip they're almost identical, and really the only difference in the Lodash library is how it handles the arguments. Does it treat the arguments as an array, or does it treat the arguments individually? Now, with that, so let's talk about day 4. So day 4 was bingo, right? Yes, day 4 was bingo. Okay, so let's look at our day 4 test. So the idea behind this was figuring out which of the boards won first when we called all these numbers in a game of bingo. Now, the first thing that I did, because again, this was an opportunity to do some object-oriented programming. So I made a board class, and that board class was responsible for parsing itself from each of these chunks of text. And then I spent some time figuring out, making sure that the board could compute whenever it was a winner. And also did some work to make sure that it would figure out if it's a win on a column versus a row. So this is really interesting. And this whole columns and rows thing and the zip operator really made this part, understanding those things, made this part work pretty well. So the idea behind this solution is we have a board, it has its rows, which is an array of number. And then we have these marks. So this is the TypeScript type annotation for basically something that has keys that are numbers and values that are Booleans. So we start with our marks at 0, and then we make our rows based on all of those rows, and we're doing some trimming somewhere around here. Apparently not. Okay. And then what we'll do is, as each of those numbers are called, so let's go have a look at our part 1 solution. So for each number in our called numbers, for each board, we're going to mark the board. And then after we mark it, if the board's a winner, we're going to return the score times whatever the number was called. So just like it described to us. And one of the things that I love about when you take the time to do object-oriented programming and you do a good job at it, reading this code looks almost exactly like reading the English description of how you should solve the problem. So for each called number, for each board, mark the board, and if the board's a winner, return this computation. What that means is that our definition for the board, so for the mark and for the is winner, this is where the magic happens. So marking a board is just setting for whatever number that is. So if they just called the number 14, that means the key in this marks object is going to be 14 and the value is going to be true. Now in JavaScript, when you try to access by a key when there's nothing there, it returns undefined. Undefined and false are kind of like they're undefined is what in JavaScript parlance or in TypeScript is falsy, which means if you put it in a conditional expression, it evaluates to false, meaning you get the false side of something. So let's talk about how that plays out. There it is. In computing whether or not it's a winner. So we have this marked rows variable. So what am I doing here? What I'm doing is I'm getting rid of all of the numbers in the rows that haven't been marked. Okay? And we're doing that using a little bit of nested sort of functional programming stuff. So I'm doing a map, and if you remember what a map does is it takes an array and produces a new array based on whatever this function does to each individual element in that array. So inside of that, I'm filtering each row based on whether or not this marks object has a mark for that number in the array. So if I've got a row that has 1, 2, 3, 4, 5, and I've only got 1, 3, and 5 marked, then what this is going to do is it's going to give me an array with just 1, 3, and 5 in it. I do that for each and every row, and then I figure out which rows are winning based on which ones still have a length of 5, meaning that row had 1, 2, 3, 4, 5 marked. By virtue of the fact that 5 things are marked in a row with a length of 5, that means that's got to be a winner. But then we're doing the same thing with columns. However, we're using this unzip thing here. So this makes it possible for me to use the exact same technique to figure it out, but I've swapped the rows and the columns using that unzip operator. And I could do the exact same thing and it'll work the exact same way if I do zip and then spread that array of arrays like that. It'll produce the exact same result. So zip and unzip, very, very related. So this is winner algorithm. All it's doing is saying, do I have a winner in columns? Do I have a winner in rows? And if so, tell me. Now, let's talk about the score. So the score is give me the sum of every number on the board that hasn't been marked. So we've got an array of rows or an array of numbers. Now, this chain operator in Lodash, this is something really, really fun that Lodash does. It lets you tack on multiple different operations, and those operations are lazily evaluated. And we're probably going to talk more about lazy evaluation maybe next week, depending on what shows up in the problems. But beyond it being lazily evaluated, one of the cool things about this is that you can chain on operation after operation after operation. So the first thing that we're doing is this flat map. So what is flat map? Flat map takes an array of arrays and turns it into a single array. So let's play with that a little bit. Let's do a flat map on our sample data here. Look at that. Instead of us having an array of arrays, it just flattens the arrays, and it turns an array of arrays into just an array with all of the things pulled up a level. So we do a flat map, then we filter out everything that's marked. So notice this bang operator, this means not. So this filter, again, filter works by, it keeps things where this is true. So if there's no mark, keep it. Then we do a sum, and then this dot value breaks us out of the chain. So that's how we score our board. So for part one, we just call the numbers and call the numbers until we get a winner. For part two, this works a little differently. And this was one of the things that tripped me up. I had a challenge with this because I didn't realize that when we called the numbers and found a winner, we needed to get rid of the boards that were the winners. Because if we didn't get rid of the boards that were the winners, we wouldn't arrive at the right answer. So this is why, if you notice, I'm replacing remaining boards using this filter. So for each number, we're filtering out. So I'm using this filter also kind of as a loop. So we mark, we check to see if it's a winner, and then we're setting this last score based on that winner. So we're going to call a number, we're going to loop through all of the boards, see which ones are winners. If it's a winner, it's not going to be in the next round, and we're going to keep the last score. So we're just going to keep doing that and keep doing that and keep doing that until all the numbers are called, and then the most recent winner, which is going to be the last winner, that's the score that we keep, and that's the one that we return out. All right. Kimberly, how are we doing with the Twitch chat?
We're doing okay. Angel of Grace said that this is a great example of building a class. She has a good comprehension of how to use OOP, but not how to build it. I don't know if there's anything else you want to say along those lines, but I did recommend that she, ask questions in Slack.
Okay, super duper. OOP can really do a great job of helping your code be more readable. One of the things that's really, really important to remember as a professional software developer is that your code is really written for humans to read. I know the whole idea behind programming is we're telling the computer what to do, and the great joy of programming is that the computer does exactly what you tell it to do. This is also the great sorrow of programming, that the computer does exactly what you tell it to. But that's a side effect of what good programming really is. Good programming explains your thought process. I use the phrase intent revealing. I want code to be intent revealing. I want to read the code and understand, what did you mean by that? What did you intend to do? What were you trying to accomplish with this code? And what I find is doing a good job with OOP gives me an opportunity to make it clear what's the intent here. So that means not just doing classes, but also good variable names, breaking apart big things into smaller things. So this is hopefully pretty readable, and it's readable because I took big problems and turned them into littler problems. You hear programmers talk about abstraction. So the idea behind abstraction is I don't need to care how I turn the input into called numbers and boards. I just need to know I can do that, because that's not what's important right here. What's important is, now that I've got called numbers and boards, what do I do with them? And that's exactly what's happening here. All right, let's go on to day 5. So day 5, I'm going to show you my Python solution first, because I feel like day 5 was just more conducive to Python. So you're going to discover as a software developer, sometimes one programming language is better suited to a particular kind of problem than another. And in this case, for day 5, Python, I feel like was better suited to this task. And let me show you why. So one of the things I did is I built yet another class, and this is a line class. So we get pairs of coordinates, and we have to treat them as lines. Now, one of the other things that I'll also call out, and we'll talk about this here in just a second, is I'm using regular expressions to deal with this parsing aspect of it, and I'll show you why this impenetrable wall of gibberish is actually better than doing a bunch of splits and stuff here in just a second. What you notice is my line class has properties like is horizontal, is vertical, and then xmin, xmax, ymin, ymax, xrange, yrange, p1, p2. Now, this coords function in my line class, this is the magic that makes the day 5 solution work well. Every line is going to have a series of coordinates. And what I'm doing in Python here is that I have my coordinates that are just a tuple of numbers. So 2 numbers. For horizontal lines, I'm using Python's range function to generate a range from 0 to whatever x range is. So what is x range? Let's go look at that. It is the absolute value of x1 minus x2 plus 1. So what does that mean? Bunch of variables. So if we have a line, and let's go look at our tests here, day 5, test.py. Okay, we have, let's look at this guy right here. So it starts at x equals 0, y equals 9, and goes to x equals 2, y equals 9. So it's a horizontal line that goes 3 spaces, 0, 1, and 2 at y coordinate 9. So this x range, so this is 0.1, this is 0.2, so this is x1, and this is x2, okay? So it's the x coordinate from the first point and the x coordinate from the second point. We're getting the difference of them, and in this case, the difference is 2. 2 minus 0 is 2, or if they were swapped, 0 minus 2 would be negative 2, and then we take the absolute value of it, and then we're going to add 1. Why? Because this range is inclusive. We have to add 1 for inclusivity. So this x range here is going to give us 3 for this line 0, 9 to 2, 9, okay? So if I want to get all of the coordinates, I want to get 0, 9, I want to get 1, 9, and I want to get 2, 9. So I've got this range of 0 to whatever this x range is, so 0 to 3. So this range function in Python isn't inclusive, it is exclusive, which is pretty typical for programming. So this range is going to give me these 3 numbers, 0, 1, and 2, which is exactly what I want. So I'm going to take my x min. Now, the definition of our x min is pretty underwhelming. It's the min of the x coordinate from the first point and the second point. But whatever the min is, that leftmost point, we're going to take that, and then we're going to add this constant c from this range, and then we're going to keep y the same because it's a horizontal line. Same kind of thing happens for the vertical stuff. Now, if it's not vertical and it's not horizontal, then we know based on the rules of what the Advent of Code problem gave us, it's a horizontal line at a 45-degree angle. So we're going to step x and y 1 step each. But this part is really fun, and we're going to talk about it here in more detail in just a second. But before we do, I want to back up a little bit. I told you we'd talk about regular expressions, okay? So this RE library in Python, this is Python's regular expression library. And if you notice, there's this big pile of gobbledygook here on line 5. This is a regular expression. Now, I will say that understanding regular expressions is an incredibly useful tool for programmers. I will also say overusing them or misusing them will get you into all kinds of trouble. So be cautious about it. However, what I want you to notice is that you've got a set of coordinates that looks like this. We need to turn that into a bunch of numbers, and we need to know which one is which. We also want to make sure that silly things don't happen, like instead of getting 90, we get 9 if we have a coordinate that looks like that. So we're going to use a regular expression to make sure that these things get parsed out of this number or out of this string correctly. So let's break this regular expression down a little bit. So whenever you see square brackets in a regular expression, this means we're going to match one digit, a single digit. Then, or one character, forgive me, sorry. So if I wanted to match, say, only the characters A, B, or C, you could do that, and that would match A or B or C. Now, when you see a dash inside of these square brackets, so like I have 0-9 here, that matches any digit. Now, when you see 0-9 plus, so the plus character in a regular expression means something special. It means one or more. So it just so happens that numbers are one or more digits. So 0-9 in square brackets with a plus after it means match a number. Now, you'll notice we've got a comma here. So this comma represents these commas here. Got another comma here. And then here's that space with the little arrow, just like that right there. But then we've got all of these piles of parentheses, and we've got this tilde at the front and a dollar sign at the end. So too few people, when they get into regular expressions, too few people use this tilde and this dollar sign, and it's really, really important. And here's why. If I have a regular expression, let's say like this one, and we want to see if it matches this string, there's a good chance it will say, yes, it matches, and the match is 2. It's not wrong, but if you were to do this, so that caret operator means this is a placeholder for the beginning of the string. And then this dollar sign, this is a placeholder for the end of the string. So what this regular expression says is only match a string where nothing but digits are in it. Then if you match that against this, you're going to get 2, 3, 4, 5, 6. Okay? So that's why these placeholders are important. Now, the last little bit of this regular expression here is these parentheses. So what do the parentheses do? The parentheses are groupings. So they say this little chunk of whatever gets matched matters. So we have 1, 2, 3, 4 groupings, just like we have 1, 2, 3, 4 sets of parentheses. So this is extracting that number from this text right here. So it's extracting that first one, and that second one, and that third one, and that fourth one. Then we can set x1, y1, x2, y2 based on that. Now, you could do a string split and another string split and make this work just fine without regular expressions. But this does simplify that process a lot. And it especially simplifies the process when you've got multiple different splits to do, that sort of thing, and when your input is relatively same. So I would strongly recommend play around with regular expressions, spend some effort trying to learn them because they can be very, very useful. Now, let's go back and talk about this diagonal line problem. So in our line class, we talked about, okay, producing all of the coordinates for a horizontal line, producing all the coordinates for a vertical line. But now we have to figure out how to generate coordinates for diagonal lines. And it's not quite so simple as just adding 1 from a range to both coordinates, because you can have 2 different kinds of diagonal lines. You can have one where the slope is positive, which means that x increases as y increases, or you can have one where the slope is negative. So x increases and y decreases as you follow the line. So we've got to figure out which way it's going. So we have this min point here. And so this is a tuple that is the x min and the y min. So this is one of the reasons why I feel like Python is better suited for this kind of problem, because tuples in Python compare for equality exactly the way you would expect them to. Meaning that if you have a tuple that has a 1 and a 2 in it, you compare it to a completely different tuple that has a 1 and a 2 in it, it's gonna compare equal true. So let's, as a matter of fact, let's play around with that a little bit. So here we are, this is TypeScript, right? So I've got an array 1, 2, and I'm gonna compare this for equality with a different array 1, 2. So same contents, different arrays. This is not equal. We can even use this operator, the sloppy equals operator. I like to call the double equal in JavaScript and TypeScript sloppy equal, and it's generally not a good idea to use it. This is false. So now let's fire up some Python. Y'all see my password? So we've got TypeScript on the left, Python on the right. Now watch this. That compares to true. Now we're using this in Python to simplify our day 5 solution. So I have this min point. So this would be the point that would be at the x min and the y min that may or may not be on the actual line, but it's that min point. And so if that min point is 0.1 or 0.2, and if you notice 0.1 or 0.2, this is just that tuple of x and y for 1 and 2. If that min point is 0.1 or 0.2, then we know that we have a positive slope, which means as x increases, y will also increase. Otherwise, we've got negative slope, where as x increases, y decreases. So based on whether or not we have positive slope, our y start is going to be different, and we're going to step in a negative direction for y as we step in a positive direction for x. So then we can walk through in this range and do this step. And if you notice, this step starts at whatever the y start was, because it might be starting at y min, it might be starting at y max, and then we have this constant from the range, and then we're multiplying either by 1 or -1 to step in either a positive or a negative direction. All right, so we're about out of time. We only got up to about day 5. I'm not surprised that we didn't get all the way through to day 7, which we do have solutions for. Strongly encourage you, download the solutions repository, or even just browse through it on GitHub. Have fun with it. Get into Slack. Ask questions. Try at these things. And we're going to be back next week, and we're going to be talking more and more about these solutions. I know day 6 tripped up a lot of people, so we're going to start with day 6 right off the bat next week, and we're going to talk about why was day 6 tricky. Thanks so much for watching. Really appreciate everybody bringing up questions. Before we go, do we have any more questions from Twitch chat?
Yeah, there actually was one a few minutes ago when we were talking about arrays, and Sean Lifestyle asked, and I need to go find it again, what you recommend for newbies on handling multi-dimensional arrays while programming, because they can get wieldy rather easily.
Great. That's a great question. I would definitely say, especially if you're using a language like JavaScript or TypeScript or Python, play around in the REPL of the REPL. So that's what I'm doing right here. So you can use the Python command to just open up an interactive interpreter, and you can just type in Python code and see what happens. You can do the same thing with JavaScript, but you know what I do a lot of times? I will open up a web page. So like, here's my, this is actually a browser window. So I can bring up my debug tools, and in my debug tools, there's a console. I know the font size is really, really small here, but then I can type JavaScript. And do stuff with it, okay? My strong recommendation would be, if you're dealing with multi-dimensional arrays, and when you hear the phrase multi-dimensional arrays, that usually means array of thing, whether it's number or string or Boolean or potato. It's array of things. I would strongly recommend just play around with a little bit of sample data. I would also strongly recommend, if you've got an algorithm where multi-dimensional data is important, write some tests and validate your assumptions, because it's going to be really, really dangerous, especially as you start getting into more advanced data structures like that. It's going to be really important for you to make sure that your algorithms, words are hard. Algorithms are doing what they're supposed to do. So if you can break the bigger problem down into smaller problems and test those smaller solutions in isolation, that's really, really, really going to help you. So play around with the REPL, and also use some unit tests to validate your assumptions and make sure that what your code's doing is exactly what you expect it to be doing. Did we have any more from the Twitch chat?
No, I think that's it.
All right,
I
super
did have a
duper.
question, Floyd.
Fire away, Matthew.
So for the regex you used in
Yes.
the last solution, why did you use 0-9 as opposed to like escaping digit, like \d?
Meaning,
I don't know if Python does that, but I think you can do that.
so
Yeah.
yeah, the reason why is because I didn't want to have to look up whether or not Python understood the \d. It probably does, but in general, I like this, and I like going back to basics, back to fundamentals with regex anyway, because a lot of programming languages, they have their own flavor of regex, and it's a little different. And I like doing things that are going to be more or less portable from one regex engine to another.
Okay.
All right, cool. Well, we'll be back next week. We're going to talk about day 6 and the solution for it, and why your solution for day 6 is probably still running and you're still waiting for an answer. See you next week.